everybody. Did you guys all have fun last night? Yeah? Woo! Too much fun? Okay, cool. So Iki already introduced me, but I'm Angelina Calderon. I am on the customer success team here at Mapbox. So one of my favorite things about Locate so far has just been like seeing all of our amazing developers and customers not only like talking about what they build, but also talking with each other. It's just like super energizing. And I'm really excited today to talk more about how people are using our tools and also other kind of leading edge technologies to kind of build better in business intelligence. So basically what that means is many businesses are looking to improve decision-making for themselves and stakeholders with the help of data visualizations. And really, honestly, we're seeing maps take a much bigger part in this. So basically today, we have leaders from organizations who are really championing emerging technology. And this is kind of my favorite line. They're pushing the boundaries, no pun intended. OK, that was definitely a joke. I really tried. For what's possible in geospatial data visualization. So don't want to take up too much time, but we have amazing talkers. The first speaker is really like thinking about high-powered indexing and analysis for data or for geospatial data. And this is honestly from a team in the UK where one of their founders like legit modeled the function of the human brain. I can't even begin to comprehend that, but that really like kind of inspired what they're building now. After that is like thinking about telling the story of Texas's power grid. Texas is a massive state with massive, massive amounts of data. And not only are they doing that, they're doing this within the confines of government IT requirements. Again, I can't even begin to like comprehend, but you're going to learn. Third up is really like thinking about making a more informed choice about where you want to live. What kind of home do you want to buy? What are the livability factors that affect where you live, where you want to live? Everything from like noise, traffic, cost of living, lots more things, you'll learn more. And then last up is really thinking about real-time architecture and construction plans. Think about like a building like this, the cruise ship terminal, where there are hundreds of stakeholders involved in a project. And not only like what are the amounts of data that go into that project, but how do these people interact with each other as the project is being built. So really, really excited to kick things off. I will not take up any more of your time. So first up is Ben Manning, and he is the VP of Product Development at Geospock. Thanks. Oh, there you go.
I'm going to stand, I think.
All right.
Good morning, everybody. Can you hear me if I lean forward? All right. So I'm Ben from Geospock. We're a UK-based company. About 50 people, raised about $15 million in Series A that closed earlier this year. Thank you. And we enable customers to analyze extreme-scale geospatial data sets. And by extreme scale, I mean billions and billions of rows of data, so petabytes of data. And our technology enables customers to interact with that data in a super, super fast, interactive way, which I'll show you. And we use Mapbox and the fantastic tool set from Mapbox to help achieve that. So without further ado, to tee it up and the problem that we're actually solving out there, I know you've seen millions of stats, so I'll race through these. 90% of the world's data generated in the last 2 years. But with that, and this one actually blows me away, a 50x growth in data analytics in the coming years, like 50x. I think that's incredible. And where's this coming from? Well, we see this connected world. Jeff, the Mapbox CEO, led with this yesterday in the keynote around sensors, picking up more data, smart cities, Internet of Things, etc. And in the coming years, the average connected person will interact with a system every 18 seconds, generating a data record, a timestamp, lat long, and the context around that data. So a lot of data. I think you get that. But this is the problem today. 90% of the value in that data is being lost. This is a big problem. The problem is driven because people can't process this data. It's expensive, the compute infrastructure needed. They aggregate the data, they sample it, they basically roll it up and then throw most of it away. That's what people are doing. And so the stories that you can tell from that data and the analytics you can get off the back of it is compromised. So we think we have a solution that addresses these problems. Our technology basically indexes these very large data sets and gets them in shape so that they can be analyzed and interacted with in a really seamless way. And this is our data visualization tool, Illuminate, and this is, of course, where Mapbox come into things. So next, I would actually want to show you the system in action so you can get a sense for it. So I'm hoping we can run the video now, chaps. So, as I say, this is Illuminate in high definition. In this data set, there are 360 billion rows of data and a whole host of different visualization modes. But hopefully one of the things that will come through here is the high degree of interactivity that this tool enables. The key thing that's happening here, and I'll come on to talk about it more, is that this data is not loaded into the browser. You can't load a petabyte of data into a browser unless you're crazy. So what we're doing is we're tapping into this data analytics engine that we have, this data indexing, and enabling the right view of data to come through. So in this tool, you've got a whole suite of different visualization, different analytics tools, and some of these custom visualizations I'll come on to explain how we've done this. So geofencing. And yeah, it's not just maps, it's also time series, there's dashboards, and all sorts in here. Okay, let's go back to the deck. Fantastic. Okay, so we started working with Mapbox a few years ago, and what we needed from a mapping solution was a web-based mapping technology to power this visualization front end. It needs to have, and this is the particular point here, a very high rendering performance to handle that data loading coming in dynamically. And we wanted the extensibility for customization to customize these views how we want them. What we're trying to achieve here is this, as I say, this dynamic data presentation. So it's a seamless user experience. You go from literally a trillion rows of data presented on a kind of space station view, but then you can go right down to a street corner. And you can do that seamlessly. You can do that in sub-second time. That was the goal that we're trying to achieve here. As I touched on earlier, the fundamental thing of how we achieve this is this sophisticated data analytics engine that is looking at different detail levels and pulling in on the fly the necessary data, rendering it and presenting it. So we also actually normalize the data being displayed. So if you have a city with lots and lots of data and then not much around it, obviously the city will stand out as a bright spot. If you then move the map away from that city, then it will normalize and present even more detail for the sort of out-of-city area that before wouldn't have showed up so much. So we use, we've customized Mapbox shaders to support that. So Mapbox GL.js is what we're working with here, customized version of that to build these custom visualizations and connect it with that Geospock analytics engine. So some examples. So we built a whole new point renderer, and over time it loads more points into the browser and presents that, so it sort of sharpens up, and that's progressive on-demand data loading. And to achieve that we had to modify the Mapbox, how Mapbox displays this, and to give us that precise control over the visual density, frame by frame, as you sort of zoom in, zoom out. Another example are heat maps. So we, again, customized the Mapbox. We use a different approach to Mapbox on their heat maps with a dynamically calculated density grid that, again, harnesses the indexing that we have in the back end and gives you that seamless zooming. So it's not pre-rendered, not pre-computed. It's dynamically created as you zoom in and zoom out. Another thing that takes that forward as well are comparison heat maps. This is fantastic for showing two data sets and the differences within two data sets. Showing the cold spots, the hot spots, to give that visual, that instant visual representation of where something is standing out. And again, this was a custom shader. And then finally, The final example is tracks, and so this is where so this is in New York, taxis coming in and out of JFK Airport, and this is visualizing the actual routes they take, snapped to the road system, and shows a speed of travel, direction of travel with animated chevrons, which you may have seen in the video. So that's it from me, I think. If you come to our website, geospock.com, then we have a showcase that you can sign up for and get your hands on this stuff and have a play with it yourself. I very much welcome you to do that and give us feedback. And of course, I'd love to have a chat with you after the session here today. Thank you very much.
Thank you, Ben. Okay, we're live again. Cool. Sweet. Next up, we have Mike Duffy, who is a Chief Application Architect at ERCOT. Mike, we're going to have you use this mic that I'm holding, actually, because we got some feedback from AV that one was a little less performant.
Okay, good morning. ERCOT is the Electric Reliability Council of Texas. We manage the Texas electric grid. And we're running a little short on time today, so the brief summary of my presentation is that if you want to manage massive amounts of data within Mapbox, it's incredible. It's not easy, but it's definitely possible. One of the goals of the electric grid is to keep things in balance. So as people add load to the system, we spin up new generators to meet that load. So we have massive amounts of telemetry that flows through the system. Right now, all that telemetry data is being managed by various systems. The goal of this project was to coalesce all that data, put our network model onto a map, and essentially, when you turn your toaster on in the morning, we want it to show up on our map. So we've got about 7,000 power line segments, about 4,000 substations, and you can drill down. You have the capability to drill down in this to the system level and get real-time data in a very narrow focus. Mapbox is an incredibly cool toy, and we keep trying to break this toy by adding more layers to the system. And right now we're at over 20 layers with all kinds of telemetry, info boxes showing up and stuff, and we haven't been able to break it. So it's in that regard, it's been an incredibly great surprise. In talking to some of the application architects from Mapbox at this conference, the way they're doing things at an architectural level makes the map layers tiled themselves. So when you bring in a very large map layer into the system, it goes through a process of tiling in that map layer itself. Okay, in this example right here, these are for load and for generation units. These are layers that are generated dynamically on the server. We bring in data, we cache it in collections on the server, and then we dynamically generate these layers every 10 seconds and update them. It's incredibly fast. It's seamless to the users. There's no flicker, and just the numbers in those map markers update. Okay, and just a couple other quick notes. We're also using the Atlas server internally. Our control room can't have any access to the internet, so we run Atlas as a standalone server for our own internal use, and I am happy to tell you that for 20 control room operators, the Atlas server can handle that load. We also have the Mapbox support and services contract. If you're running critical infrastructure, if you have high availability needs, it seems like money well spent. And the next part of the project that we're doing is we're going to bring weather data into the system through multiple layers. And we have people going, yeah, that's great. There's not an easy, elegant way to do that right now. One of the things I've told Mapbox is that in this project, we will write a wiki that will be available for everyone to use. We're going to use WDT, which is this company in Oklahoma, for our weather data source. And we're also working with an incredibly cool company from Seattle called Integral GIS to help us in this part of the project. I'd highly recommend those guys. They're really good guys. But again, in summary, if you have lots of data and you want to visualize it in Mapbox, it can be done.
Thank you, Mike. Yeah, that was awesome. Cool. I've been instructed to talk from the stage. Sweet. So next up, we actually have two presenters. We have Tony DePace and Piro Lera from Solaria Labs at Liberty Mutual, and they're going to talk about all the amazing projects they work on. Come on up. Yeah, that one's not as live. Are you guys good handing off?
Yeah, that's fine.
Okay, cool.
All right, can you hear me? Hi. Hi, everyone. I'm Piro, and this is Tony. We're going to talk about Total Home Score today and how Mapbox is helping us with visualizing our data through the front end. Just to go next. A little bit about ourselves. So Solaria Labs is an innovation lab within Liberty Mutual, the big insurance company. We've heard a lot of talks yesterday, for example, on how autonomous cars are coming. They're almost here, so you can imagine that that's a big disruption to the insurance industry. So the goal for our lab is to make sure that we can diversify at least the Liberty Mutual portfolio through new innovative ways. And we focus on a few channels, sharing economy, home protection. Mostly what we're going to focus today is more on the analytics and data services work that we've been doing, specifically the Total Home Score, and how that's available through the Shine API that we're providing. More on the details. So what is the problem that we're trying to solve? Usually people live in their house for 7 to 10 years, and on average they spend less than an hour trying to figure out if that's the home that they're trying to live in. So usually you could do like a home inspection, you could go through a home open house, maybe you drive through the neighborhood, but you don't have a lot of data that you're making a huge decision for where you want to live for the next 7 to 10 years. And let's say in Boston, San Francisco, you're probably going to spend more than $1 million buying that house. But you're only basing that information based on just the 1 hour that you spend in that particular house. And not only that, but we did a study and that showed that this is a huge problem in terms of size. 4 to 10 people would reconsider buying their house knowing what they know now from a livability perspective. So think of, let's say, what the neighborhood vibe is, how much noise you have in your home, what the traffic is around the area that you're going to live in. So if you had that information when you were purchasing the house, you probably, or 4 out of 10 people would probably make a different decision had they know that information. And that combined with the fact that there's about 137 million homes in the US, it's about 53 million people that would probably make a different decision if they had some more information in this data-starved type of solution for what it is right now. And so our solution has been the Total Home Score, which is a combination of these livability factors at the address level. And Tony's going to focus a little more on why that's very important to have it at the address level rather than at the neighborhood level. And there's two parts to this solution. We make this data available through, let's say, JSONs through an API, but also we have a front-facing website, and you can see here, powered by Mapbox, on how to make this data available to the normal user, not just the developers through the API. And you can see that this is a map of Boston. That's what we're based on. And this is, I think, the quiet score. And you can see that why it's important to have it at the very specific address level. Like, there's quite a big differentiation between even like 2 houses next to one another or 2 buildings next to one another. And it's, in this case, green is good, by the way, and red is bad. But it's very important to have it at the address level and then provide this information in an easy-to-use way for both developers and homeowners and the general population. So Tony's going to focus a little more on the details now.
Thanks, Piro. So currently, Total Home Score consists of 5 scores. The first score being quiet score. And this is just, how noisy is the area that you want to live in. We leverage several data sources, including OpenStreetMaps, and we try to focus on factors that might not be easily noticeable through like an open house or something, like proximity to a subway. We were using aviation data, like are there going to be a lot of planes coming over? We also have a road safety score, where we leverage Liberty daily driving patterns to see, is there a lot of speeding on the streets near this home? Is there hard acceleration, hard braking? Those kind of things. If you're moving into a house with kids, you might not necessarily want to live next to a busy road. We also have an errand score. This is, how easily can I run my errands? Proximity to, grocery stores, pharmacies, that kind of thing. Traffic score. If you're getting a tour on a Sunday, you're probably not getting an accurate estimation of what, the daily traffic is going to be like. So again, we leverage, some of these daily driving patterns, OpenStreetMap data, to see is it going to be hard to get to work? It could take 2 hours to get across Boston from some places. Then we have the entertainment score. Similar to errand score, we're saying, are there a lot of restaurants in this area, bars, clubs, those kind of things. we also think it's important to explain, why one score is better than another. So we provide major, moderate, and minor factors why you might have lost points on an address. And this could be anything from like the proximity to like a subway, or there are lots of flights that go over. The explainability of a model is very important to the customer. So as far as why we chose Mapbox, our front-end website's really just kind of a demo tool to explain to customers, senior leadership, and for the data science team to validate their models. We want it to be fast, interactive, and very intuitive. Mapbox allows you to pretty much automate the whole process. Once we get new data from our data science team, we really just have to run a few scripts, and it'll combine our total home score data with OpenStreetMap building geometries, create a GeoJSON file. We use Mapbox's Tippecanoe command line tool to create vector tiles where we can specify any zoom level that we want on the map tiles. And then from the front end, it's very easy to get going with data-driven styling using Mapbox's GL JavaScript library. We found great performance even on mobile, and there's tons of examples and documentation to get going very, very quickly. So I wanted to give a few examples of why these scores are powerful and what they can really help the customer to make an informed decision when buying a home. So this is an example of the Beacon Hill area in Boston. This is like a residential type neighborhood. You can see at the number 1 pin, there's a red line that goes through the map. And there's not really like a street that goes through there. So if you were going on an open house on like a Sunday morning, you probably wouldn't notice that much noise. But the reality is that there's an underground train that goes through there. And after talking with people who have lived there before, they said it's very noticeable, and they might have made a different decision had they known that beforehand. As far as road safety score, this is another neighborhood in Boston, Jamaica Plain. It's, again, a very residential area, a lot of small roads, but it's in kind of close proximity to a rotary. And when we first saw this, we thought there might have been a problem with our model. We didn't know how to explain it, but when we dug deeper into the data, it turns out that a lot of people were cutting through these residential streets to avoid the traffic during their commute. Again, probably not something you would notice during an open house, but if you're bringing your kids to a home, you probably want to avoid the roads with lots of speeding, acceleration, that kind of stuff. So we're in the very early stages of this product. We have full coverage in Massachusetts, also coverage in Chicago, and over the next couple months, we're hoping to expand nationally. We have several pilots that have signed up with us, and some of them display the data to like realtors, home buyers. Some of them use it for predictive modeling, for pricing on homes. And even internally, we're looking at use cases for the data. So it's really exciting, and hopefully there'll be more to come. Thank you.
Cool. Thank you, Tony and Piro. Awesome. Next up, we have James Wagner, who is the founder of an amazing project called Project Atlas. Come on up, James.
Thank you very much. Mind control here. Yes. All right. Well, like I said, thank you very much. I am James. I'm with Project Atlas, and we are bringing location-based project management to the construction industry. So you just saw up here, buildings we've all been in, hospitals, universities, convention centers like this. But if you just take a moment to think about the complexity and the challenges that go along with taking millions of dollars in raw material and assembling it all together into one structure, taking each little piece and putting it in the right location. It's a huge, complex problem, and it's amazing that it all comes together. In addition to that, construction really matters to all of us. It's estimated we spend 90% of our time indoors. And I don't know, maybe here in California with the beautiful weather, it's a little less than that. But I can say in Texas, when it's 100 degrees in the summer, that's definitely true. And construction also takes up a ton of our resources. By 2030, $17.5 trillion will be spent a year on construction. And lastly, this was alluded to in the keynote here at Mapbox, that the urban population is going to double over the next 30 years. So, we've built up our city infrastructure over 2,000 years. We're going to have to do that again in just 30. So in order to pull that off, we need the best people, the best processes, and importantly, we need the best technology in the construction industry to get that done. But unfortunately, this is a metaphor for where the construction industry is at today. Now, I don't know if any of you ever had to drive with one of these. I was lucky that I started driving after iPhone came out. I never had to worry about flipping through. But I remember every road trip we went on as a kid was guaranteed to involve my parents arguing over one of these, my dad holding it upside down, pulling out pages, putting them side by side. But we have a better solution to this now in our personal lives. We have digital maps. And not only have digital maps made directions easier, it's opened up new opportunities like real-time traffic and gas prices at every exit. And it's even enabled new services that we could never have imagined before, like Uber and like Uber Eats and like Uber Bikes. So all these things we couldn't have imagined without the digital map. So again, this is one of the buildings we showed on the first slide. And this here is what you might think that the blueprints would look like for this project. You'd think you have one continuous map that that's easy to consume and to look at. But unfortunately, that's not the way it is. So even though the architects design these buildings in a rich 3D modeling environment, they're still chopped up into individual pages and before they're sent out to the construction team. And so as you can imagine, when it's split up like this, you lose that continuity, you lose the context of the full building, and you lose the ability to align data together geographically. So in addition to this, you see that one view is split up into 7 different sheets, but there are separate sheets for architectural and electrical and HVAC and IT and so on. So this particular project had 6,500 drawings that you had to keep track of. So at Project Atlas, we are making the digital map for construction. It's a new way to visualize your construction project. So we take those models from the architect, we project them into real-world coordinates, and that opens up the gate for us to align it with all other types of real-world information. So you can see here we're pulling in drone imagery from Drone Deploy. We're pulling in street maps from Mapbox. We have the team's location there spread out across the map so you can coordinate with your team members. And we have issues and information all stored by their geographic location, not tucked away in a database, not tucked away in a file system. So we talked about issues. On a construction project, there are thousands of issues and punch items that have to be tracked. If you can imagine, if your job at the end of a construction project is to go around and inspect every electrical outlet to see if there's voltage running through there, I mean, how do you do that without a map? So that's something we're working on. And then also visualizing that data. As software developers, we've gotten really good at iterating, improving, getting insights on how we're working and on how we can improve. The construction industry has a ton of data, but it's lost at the end of a project. They say we're going to do better next time, but there's no actionable insights that they can start from. So in this example here, there are a lot of issues in the center of the building. Well, maybe that means if we had loaded our equipment from the sides, we could improve upon that problem. So being georeferenced also lets us pull in other sources of georeferenced information. So we've got a weather map here provided by Eris Weather, which is a great service that we've partnered with. But if you can imagine, so you've got hundreds of people out on a job site. If we can send you an alert that says, there's inclement weather coming in 30 minutes, get yourself out of a dangerous situation, get to safety, that can have a real valuable real-world impact. And then also, as I alluded to, the digital map opened up services that we never could have imagined in our personal lives, and we want to do the same thing in construction. So video is not playing here, but the idea is that we can have Uber for construction. You can see where all of the heavy machinery is on the job site. I can summon a scissor lift to my location, and even just down to power tools. I know just in my personal life, if I'm starting a project, in my own house sometimes I can't find the tools I'm looking for, so you can imagine what it's like on a job site. So we're excited for the future of what location can mean to the construction industry, and we're going to make this happen with the power of location data, with the power of Mapbox, and we're excited to see the future. So thank you all.
Cool, thank you everybody. So it looks like we have a few minutes for Q&A. If I can have the speakers come on up. Come on over. And yeah, from the audience, anybody have questions from all of this information you just saw? Noemi will be out there with the mic.
Questions, comments?
Did I see a question out there?
Anyone have a question?
Okay, come on, honestly, do not be shy. Here we go, here we go.
So looking at the home quality assessment, when does that come to San Francisco?
You can answer this, but I think it's in the next few weeks that we're going to go nationally, so it's more just computing the data, all the algorithms are there, it's more getting it into production right now, so maybe a few weeks, I'm hoping.
Yeah, I think we're shooting for like mid to end summer. Yeah, we have several clients that want specific locations, so not exactly sure where San Francisco falls on that, but we're hoping by the end of summer to have national coverage, hopefully.
Raise your hand, let's go. Who's working with big data? These guys have tried it all. Wow, really? Don't make me pick you out. I saw movement. Seriously? I want to hear more about Tippecanoe. Okay, great, thank you. I'm asking my own question.
So I know the tile sets make it really easy when you have a large amount of data to send like GeoJSON to your map. But when you're doing data-driven styling and you need information about the styles, do you have any ways that you can quickly transfer that data to your client?
Yeah, so for our data-driven styling, we put the score information in the GeoJSON, so that's in the tiles, and then with the Mapbox GLJS library, you can access those properties and like set the the color of the buildings, for example, to be that property. So we don't actually send it to the client in real time. That gets streamed to the client with like the whole tile, and then the GL library handles all the styling and handling that information.
And the way we're doing it is that we dynamically generate the layers on the server itself and just apply styling dynamically as those layers come down. And we have a lot of, the initial vision was that we would stream all this data in through WebSockets. It would all be managed in the browser. We found that Mapbox did fine in the browser, but a lot of the other JavaScript functionality to process that data broke. So now we make AJAX calls on some sort of time frequency every 10 seconds, goes out, gets the layers, gets the data, processes it incredibly fast from the server down to Mapbox, and it's the way to do it rather than stream it through WebSockets.
Oh yeah, so Mapbox is set up with layers, just makes it really easy. So for us, we swap colors, we swap visualizations, and some of that data is stored into the tiles as properties. Other style properties we let users control, but it all re-renders incredibly quickly and with great performance. Absolutely.
Anybody else
Mapbox is the bomb.
I was going to say, anybody else working with trillions of data points? I have a lot of questions about that, but this is your show.
Yeah, what James just said about Mapbox being so cool, before ERCOT, I spent a lot of time in oil and gas working with Esri, and if you're trying to make a decision between the two, I would suggest Mapbox, and if you made a decision for Mapbox, you've made the right decision.
Yeah, we agree too.
Cool. All right. Well, hey, thank you so much, everybody. That's going to be a wrap. We have the keynote here at 11:15. That's going to be upstairs. One massive round of applause for the amazing panelists and Angelina.